strong and weak acids and bases. HCl and HF, hydrochloric and hydrofluoric acid, these look pretty similar, right? Fluorine and chlorine are sisters in the same family. The formulas are similar. We'd say, well, these are very, very similar. But there's some important differences between them. HCl is what is considered a strong acid, and HF is a weak acid. A strong acid is one that completely ionizes in solution. You put HCl in water, it gives up all of its hydrogen ions to the water. But when you put hydrogen fluoride, or hydrofluoric acid in water, it's a weak acid. It only ionizes a little bit. Strong and weak have nothing to do with how dangerous these acids are. HF is actually a very, very corrosive acid, even though it's considered a weak acid. So if we look at HCl, we put HCl in, all of the chloride ions have given up, have donated their protons. And when we write the chemical equation, we have a single arrow here indicating that this goes to completion. There's no reverse reaction going on. Strong acids are strong electrolytes. If we look at a 1.0 molar HCl solution, then the hydronium ion concentration will be the same. It'll be 1.0 molar. So here is where the book talks about those brackets that we saw out of context in chapter 15. The bracket around the X means the molar concentration of whatever's inside of it. So the bracket tells us the concentration of hydronium ions in molarity. Pure water doesn't conduct electricity. Now, why is it dangerous to be around water and electricity? Because if you're standing with the electric leaf blower in a puddle on the back patio, the water you're standing in is not pure water. It's got dirt and stuff in it, right? Tap water does conduct electricity. Pure water doesn't. Pure water, this is a cool conductivity device that I wish we had one that worked, but we don't. I should make one. The light bulb won't go on. This is plugged into an outlet. The light bulb won't go on because the electricity cannot get from one electrode to the other through pure water. If we throw some hydrochloric acid in there, it completely dissociates into ions. There's now hydronium ions and chloride ions, and the ions carry the current from one electrode to the other, and the light bulb goes on. A strong electrolyte conducts electricity strongly. A strong acid conducts electricity strongly. There are 6 strong acids, and how you know which are the strong acids is you remember them. These are the strong acids. Monoprotic acids have one ionizable proton, one proton monoprotic. We saw an example of a triprotic acid earlier. Sulfuric acid is an example of a diprotic acid. It's got 2 hydrogen ions. And it's actually only strong in the first ionization, but that's not going to matter for us.